Connective tissue proper. Connective tissue proper may be divided into four major categories: loose connective tissue, dense connective tissue, reticular tissue, and adipose tissue. Each of these different types possesses specific characteristics and functions. Loose, areolar, connective tissue. The extracellular matrix of loose, areolar, connective tissue is composed of a loose, apparently haphazard arrangement of types I and III collagen fibers interspersed with long, slender elastic fibers embedded in a gelatinous ground substance. Cells of connective tissue proper are also present in healthy loose connective tissue, and they are nourished by the extracellular fluid that percolates through the ground substance as it leaves the abundance of arterioles and the arterial side of capillary beds to return to the venous side of capillary beds and to the profusion of venules and lymph vessels. Loose connective tissue is present deep to the skin and envelopes neurovascular bundles. Reticular tissue. Reticular tissue, composed mostly of type III collagen fibers, constitutes the net-like framework of some organs such as liver, spleen, bone marrow, smooth muscle, adipose tissue, and lymph nodes. Usually, reticular fibers are manufactured by fibroblasts, although the smooth muscle cells manufacture type III collagen fibers in smooth muscle. Dense connective tissue. Dense connective tissue is much richer in fibers and much poorer in cells than loose connective tissue. Depending on the precision in the orientation of the fibers, dense connective tissue may be classified as irregular or regular. 0. The type I collagen fiber bundles of dense irregular collagenous connective tissue are arranged in an apparently random orientation that provides this tissue a great deal of flexibility and elasticity, but at the same time imparts to it the ability to resist tensile forces. Dense irregular collagenous connective tissue forms the dermis of skin, the capsules of many organs, and the connective tissue sheaths that surround nerves and larger blood vessels. Dense regular connective tissue is of two types, collagenous and elastic tissue, depending on the majority of the fiber type composing it. Dense regular collagenous connective tissue forms tendons, aponeuroses, and ligaments. It is composed mostly of thick, coarse, parallel bundles of type I collagen fibers packed so closely that only a scant amount of ground substance and compressed fibroblasts are present among the fiber bundles. Dense regular elastic connective tissue is composed of densely packed elastic fiber bundles disposed parallel to each other with fibroblasts among the bundles. Dense regular elastic connective tissue is arranged in perforated sheets, as in the fenestrated membrane of the aorta, or as thick, short bundles, as in the ligamentum nuchae of the spinal column. Adipose tissue. There are two categories of adipose tissue depending on the type of fat cells that compose it. The unilocular fat cells of white adipose tissue or the multilocular adipocytes of brown fat. Brown fat develops prenatally, whereas white fat develops postnatally. Brown, multilocular, adipose tissue is even more lobular than white adipose tissue, and in contrast to in white fat, the nerve fibers serve blood vessels and the multilocular adipocytes. In appearance, brown fat is present only in embryos and neonates in humans. After birth the fat droplets coalesce to appear as if they were unilocular. In some older individuals with wasting diseases, multilocular adipocytes may reappear. White, unilocular, adipose tissue consists of unilocular adipocytes, arranged in lobules that are incompletely separated from each other by connective tissue septa that convey nerve fibers and blood vessels to the tissue. The rich vascular supply forms extensive capillary beds within the lobules so that each adipocyte is closely associated with nearby capillaries. In addition to its location in the subcutaneous connective tissue, omentum, mesenteries, and buttocks, there is also a gender-specific accumulation of white adipose tissue. In women, it is prominent in the breasts, hips, and thighs, whereas in men it is prominent in the neck, shoulder, and hips. Multilocular adipocytes are prominent in animals that hibernate. These cells, on the proper signal, the release of norepinephrine from nerve fibers synapsing with multilocular fat cells, begin to generate heat and bring the animal out of hibernation. Brown adipocytes are able to generate heat because the inner membranes of their mitochondria possess a transmembrane protein, known as uncoupling protein 1, UPC1, also known as thermogenin, that is specific only to these cells. UPC1, instead of permitting the e-flow of protons through the enzyme complex adenosine triphosphate, ATP, synthase, directs a reverse flow of the protons, uncoupling oxidation from phosphorylation. The proton flow, instead of generating ATP, is dissipated and generates heat. The blood in the rich vascular supply of brown adipose tissue is dispersed throughout the animal's body, and the increasing body temperature brings the animal out of its hibernating state.